Have you ever looked at your solar setup and just had that nagging feeling that you're not getting the power you thought you would? You're not alone. Today, we're going to dig in and figure out how you can test your panels yourself and see what's really going on up there. It's the ultimate mystery for any DIY solar enthusiast, right? The label on your panel says, say, 395 watts, but your system is telling a totally different story. So, is the panel broken? Did you mess up the wiring? Well, the answer is a little more interesting than that, and we're about to solve this puzzle together. All right, let's get started. First things first, if you want to get real, accurate answers, you need the right tools for the job. So let's talk about the essential gear you're going to need. Now, you might have a standard multimeter kicking around your workshop, and that's great, but for solar projects, a clamp meter is what you really want. And here's why. It lets you measure the flow of electricity, the current, without disconnecting a single wire. That is a huge, huge advantage for what we're about to do. But listen, not all clamp meters are created equal. The number one most important thing is that it has to be able to measure DC current. A lot of the cheaper ones only do AC, so watch out for that. A model like the Ideal 61747 is a fantastic example, because it's super versatile. And hey, look for some of these cool bonus features. A secondary screen? Seriously, that's a lifesaver when you're in a weird spot. And a thermocouple to measure panel temperature? Oh yeah, you're definitely going to want that. It's a critical clue in our investigation. Okay, you've got your tool in hand, so let's get down to business. We're going to start with a really basic health check on the panel itself. Think of it like we're taking its pulse and its blood pressure. So these two vital signs are called open circuit voltage, we'll call it VOC, and short circuit current, or ISC. The VOC, that measures the panel's potential energy. It's like the water pressure building up in a garden hose when the nozzle is shut. The ISC, on the other hand, that measures the actual flow of electricity. That's what happens when you open that nozzle all the way up. If both of these look good, we know the panel is fundamentally healthy. Measuring VOC is super easy. Just set your meter to DC voltage and connect your red and black probes right to the panel's connectors. Now, when you get a reading, don't be surprised if it's a little lower than what's on the sticker. For example, a panel that's rated for 41 volts might only read something like 37.6 volts. That is totally normal, and I'm going to explain exactly why in just a minute. Now for the short circuit current. You'll switch your meter over to DC amps and use that awesome clamp feature. All you do is clamp it right around one of the main wires coming off the panel. For a 395-watt panel in bright direct sun, you should be seeing something right around 12.4 amps. If your Vogue and ISC numbers are in that ballpark, then congratulations. Your panel is perfectly healthy. So wait a minute, if the panel's healthy, then why isn't it producing the full power that's printed on the label? Now we get to the heart of the mystery. This is where we separate the perfect, sterile world of a laboratory from the messy reality of your roof or backyard. You see, that number on the sticker was measured under something called Standard Test Conditions, or STC. This is a lab setup. We're talking crazy powerful, perfectly angled lights, and, this is the most important part, a cool panel temperature of about 77 degrees Fahrenheit. It's a perfect storm of ideal conditions that, let's be honest, almost never happens outside. So who are the real-world culprits stealing your power? Well, there are two main offenders. Number one is heat. The second a solar panel gets hotter than about 75 degrees, its voltage starts to drop. And number two is the sunlight itself. You know, the intensity, the angle of the sun, a cloud passing by, all of that directly affects how much current your panel can produce. I love this analogy. It just makes so much sense. Think of your solar panel like a world-class runner. That number on the label, that's their personal best record, set on a cool, perfect morning. But measuring its output on a hot afternoon is like asking that same runner to match their record while sprinting in 100-degree weather. They're still a fantastic runner, but the conditions are absolutely going to slow them down. Let's put some hard numbers on this. Here's a panel rated for 41 volts under those perfect lab conditions. But on a sunny day, when the panel itself heats up to a blazing 122 degrees Fahrenheit, its actual voltage drops down to 37.6 volts. That's a real drop. This effect is called derating, and it's a completely normal, expected part of how all solar panels work. Okay, everything we've done so far is with a single disconnected panel, but what if you want to test your whole system while it's actually running and making power? Well, for bigger systems with higher voltage, we need a safer and more stable way to do that. See, once you start wiring panels together in a series, that voltage adds up fast. It can easily get over 100 volts. And trust me, trying to hold two little metal probes steady on a live system like that is not just hard, it can be downright dangerous. We need a secure, locked-in connection. And check this out. There is a fantastic DIY trick for this. You can make your own custom safe test leads. Just grab a cheap set of meter probes, snip the pointy ends off, and then crimp on a set of standard MC4 solar connectors. Then you can use some Y-splitters to plug these right into your array. It gives you this solid, hands-free connection so you can safely measure everything while the system is running at full tilt. Okay, we have covered a ton of ground. You now have the tools and, more importantly, the knowledge to really understand what your solar panels are doing. So let's wrap this up with the key takeaways that are going to empower you on your solar journey. Let's just drill this down. Remember, always start with the right tool, a DC clamp meter. Check those two vital signs, the VOC and ISC, to make sure your panel is healthy. And the big one, understand that the number on the label is a lab benchmark. It is not a guarantee for your backyard. It's the heat and the angle of the sun that dictate your real-world performance. By learning how to measure your output, you've done more than just learn a new skill. You've unlocked the ability to truly understand and optimize your entire system. Now you can experiment with tilting your panels. You can check for shading problems. You can even see if cleaning them makes a difference. And you can do it all with real data. The power is, quite literally, in your hands now. So the only question left is, what are you going to do with it?